Hello ChemComm. Today we're going to take a look at what happens when we add something called a functional group to a hydrocarbon and how that changes the properties of the hydrocarbon. Let's get started. We've talked previously how builder molecules or monomers can be added together through an addition reaction to create a polymer. We've also talked about how some of the legs on those monomers can be replaced or substituted with other elements in order to change the properties of the polymer. There are other groups we can add to the entire polymer called a functional group. And today we're going to take a look at some of those different types of polymers and how we name them. I'll tell you here from the beginning, there's going to be lots of different types that we're going to work through, and there's going to be a lot of information really fast, but we're going to organize this all into a chart at the end that'll help you name and identify them correctly. Just one quick thing here before we get started. When we show this polymer with the functional group attached, we'll use the term R to represent the rest of the molecule and then show the functional group attached to R, which is however many carbons are in that chain or in that backbone of the polymer. Let's go ahead and get started with some of these types of polymers. The first type we're going to look at is called an alcohol. The functional group for an alcohol is an OH, an oxygen and a hydrogen that's bonded together that's coming off one of the carbons in the carbon chain. So the general formula would be R, a certain number of carbons, combined with that OH. The way that we name these is we're going to name the carbon chain as an alkane. So for instance, if there's 2 carbons in the chain, we'd just say ethane. And then we're going to take the E off and add OL as an alcohol. So if we have 2 carbons, that's ethane. And then we see our alcohol group on the end, so this would be called ethanol. Here is 3 carbons, so that would be propane. We take the E off and put propanol, but also notice this has a number. That number is there telling us which carbon it's coming off of. Remember, we always count from the short side, so this is 1 because we can count these as 1, 2, 3. So this would still be the first carbon that the OH group's coming off of, making this 1 propanol. In this second one here, we have propanol again. There's 3 carbons, but now the OH group, or the alcohol group, is coming off of the second carbon. So this is 2 propanol, and that's the alcohols. The next one we're going to take a look at is the aldehydes. Aldehydes are when you have an aldehyde group, a CHO, that's coming off of one of the carbons in the carbon backbone. The way we name these is we name the carbon chain, so methane, ethane, butane. We take the E off and we put the AL, but there are no numbers present. The reason there are no numbers present with aldehydes is because the aldehyde group will always be at one of the ends of the molecule. So here's methane with 1 carbon, so this just becomes methanol. Here's 2 carbons, so ethanol, and 3 carbons, propanol. Sounds a lot like alcohols, but you can see that the structure of these is very different. The next type here are called carboxylic acids. This is 1 carbon double bonded to an oxygen and then single bonded to an OH group. The way we name these is to first name the alkane with that number of carbons. Then we take off the E and we add oic acid to the end. So if you look here, you see that we have a carboxylic functional group and we only have 1 carbon. So this would be methane, and methane would become methanoic acid. Here's 2 carbons in the chain, so ethanoic acid, and here's 3 carbons chain, so propanoic acid. This is where some of these functional groups get a little trickier, and the reason they get trickier is because they get inserted kind of in the middle of the chain. This one is called esters, and esters is a carbon that's single bonded to an oxygen that's inserted in the chain and then double bonded to another oxygen. Because it's in the middle of the chain, you're going to have a short side of the chain and a long side of the chain. If you look here at the examples, you can see here's the carbon double bonded to an oxygen, and then there's another oxygen that's within the chain. So we have a short side with only 1 carbon, and then we have a longer side with 2 carbons. We're going to name the side without the double bonded oxygen first. We're going to find the prefix based on the number of carbons, and we're going to add YL to the end. Then we're going to name the side with the double bonded oxygen, and we're going to change the ending of that side with O8. So with esters, you're actually going to use 2 prefixes, one for the side without the double bonded oxygen and one for the side with it. And that's exactly what they've done here with these examples. You can see here that this is the side without the double bonded oxygen, and there's only one carbon. So we have methyl, and we put YL at the end. So this is methyl right here. And then the side with the double bonded oxygen has 3 carbons. So that's propane, and we change the ending to O8. So this is methyl propanate. If we look here, the side without the double bonded oxygen has 2 carbons, so that's ethyl. And the side with the double bonded oxygen also has 2 carbons, so that's ethanoate. And then finally here we have 4 carbons in the non-double bonded O side, that's butyl, and then we only have 1 carbon on the double bonded side, so that's methanoate. That brings us to ethers. Ethers are kind of like esters in that they have an oxygen atom in the middle of the chain. In this case, we're going to find the shortest chain of carbons first, use the prefix, and add the ending oxy. Then we're going to name the largest chain of alkane and put the 2 together. So if you look down here at the bottom, the shortest side is with 1 carbon, so that's methoxy. And then we have 2 carbons on the other side, so we just say ethane. On this one, we have the short side has 2 carbons, so that's ethoxy. And then we have 3 carbons on the other side, so that's ethoxypropane. The last functional group here is the ketones. The ketones is when you have a carbon double bonded to an oxygen in the middle of the chain. All we're going to do here is name the alkane chain, remove the E and add one or O-N-E, and then we might need a number to tell where that double bond is taking place. So if you look here, this is 1, 2, 3, 4, 5 carbons, so that would be pentanone. And then we'd put a 2 showing that the double bonded O is off the second carbon, so 2-pentanone. And then this over here would be 2-butanone because there are 1, 2, 3, 4 carbons. I know that seems like a lot of different molecules and a lot of different naming rules. We are going to give you a reference sheet and we're going to walk through how to use it to make sure you can identify these molecules and come up with the correct name. Before we get to that, let's talk about how some of these molecules get put together in polymers. Most of these monomers or builder molecules had an OH group somewhere within the monomer. So if we take those 2 OH groups and we put them together and a bond occurs at that spot, what'll happen is water will come out of that bonding site and the site will be bonded together by one of the leftover oxygens. You can see this here down at the bottom. We have 2 OH groups, and if we take 2 hydrogens and 1 oxygen from that bonding site, it's going to make water. Then there will be an oxygen atom bonding those 2 molecules together. We call this a condensation reaction because it produces water. One example of this is how we make plastics to form plastic water bottles. Another example of this is actually the production of nylon. Here you have a polymer with an OH group, and as those OH comes together, water comes out and a bond occurs between these monomers, which produces long, stretchy nylon polymers. All right, now let's take a look at your functional group reference sheet. If you look in your packet, you should see something like this. At this point in time, we've gone through all different types of organic molecules, alkanes, alkenes, alkynes, and the different functional groups we can attach to them. So if you look, this chart literally not only shows you the name, it also shows you the general formula for each. It gives you an example of what it would look like. You can see alkynes here have a triple bond. You can see a cycloalkane is going to be a ring structure. You can see an aldehyde has a carbon with a double bonded O and an H at the end. And then probably the most important thing, it gives you an abbreviated version of the rules to name these items. And then it'll give you an example here to the right. This reference sheet can be used on all quizzes and tests and becomes very helpful when you're looking at a molecule that you're not quite sure what it is. So now let's flip that over and look at the back. Before you get to the naming side of this sheet, you might have to identify what molecule it is you're looking at. This side is for identification of type. So if you look up at the top, it's kind of like a dichotomous key where you answer questions and work your way down until you know what type it is. So let's practice this using one of the molecules from your activity. Here's our molecule over here. I just threw a bunch of different types of molecules at you, and you're probably looking at that thinking, I have no idea what that thing is. So let's start at the top. Are there any oxygens in this molecule? Well, yes, there are. So now we're over here. How many oxygens? Well, there's one there, and there's one there. So there are two. Is there an OH group? Well, yes, there is. It's right there. So that means that this is a carboxylic acid. So we've identified this type as carboxylic acid. Now that we know the type, we can go back to the side that shows us the naming rules for the carboxylic acid, and we can name this thing appropriately. So here we are. So we go down to carboxylic acid. It says count the carbons and name the alkane. So there are two carbons. So this would be ethane. Replace E with oic. We take off the E and put oic. Add acid to the end. Acid. Ethanoic acid. So all you have to do is use the one side to identify what you're looking at, and then the other side to walk through the naming rules, and you're going to come up with the correct name. Another way you can use this chart is if I ask you to draw the molecule. So in this case, we have something called propanol, and I want you to tell me what it is. What I would do here is I would look for the model to the right, the name, example names. And you can see that this ends in NOL, and we know that alcohols always end in OL. We can even see that in the naming rules. So now we know that whatever molecule we draw, it's going to have an OH group at the end, just like an alcohol would. The next thing we need to decide is how many carbons would this have. It's propane, so that's 3 carbons. So all we'd have to do is draw a chain of 3 carbons attached to this alcohol group. Notice this doesn't give us a number, so in this case we'd probably put the OH group toward the end of the molecule. You could also draw in the hydrogens around these carbons to make sure they each have 4 bonds. So you can see that this reference sheet is very important. You have your own copy, and we'll also have copies in the room. My advice to you right now is take your time and do the activity. Make sure you can use this reference sheet correctly, draw some molecules, and name some molecules. Let me know if you have questions. We'll see you soon.